Welcome back. In the previous video lecture, you learned about the basic principles of the energy balance. We constructed an energy balance using the primary energy source gas as a reference and related energy flows due to the conversion into secondary energy carriers, distribution and consumption in the various relevant sectors. In the second part, we will construct the entire energy balance representing the energy infrastructure of the European Union as shown in this Sankey diagram. Let's start again with the total primary energy sources. This includes coal, oil products, gas, nuclear heat, renewables and waste. I have filled in the corresponding numbers for the European Union in 2023 case. As you can see, the export of the various energy sources is presented in negative numbers and production import in positive numbers. In addition, the row in yellow highlighted, corresponding to bunkers and stock exchange, is not yet introduced. We have not discussed this category for the previous gas example. This row is related to bunkers for the international shipping and aviation. International in this context means going outside the European Union. These bunkers account for the energy delivered to airplanes and ships which are leaving, in this case, the European Union. On the contrary to the inland shipping and domestic aviations, which are part of the transport sector within the European Union, the international bunkers cannot be assigned to a specific country or a specific region. Hence, it's not included in the domestic energy use. As you can see, the number is logically the largest for the oil products used for the international transport. The import and export of electricity is in balance, so there is no net total primary electricity. In the total column shows the total production, import, export and bunkers summed over all the energy carriers. The total primary energy sources for the European Union in 2023 were 1,255 megatons oil equivalent. The energy balance also includes a column entitled Waste. This column includes the generation of power or heat from trash using methods like combustion, also referred to as incineration. I did not include it in the Sankey diagram as it only has a minor contribution of about 1% to the total primary energy consumption. Nevertheless, it should be noted that waste as energy carrier is always included in energy balances. Next, we will consider the conversion of the primary energy sources into the secondary energy sources. As you know by now, this is the middle section of the energy balance. Let's first consider oil and oil products. As mentioned in the previous lectures, oil is referred to as crude oil, which is the raw, unrefined fossil fuel extracted from the underground reservoirs. Crude oil is a liquid mixture of hydrocarbons. Oil products are finished products like gasoline, kerosene, diesel, heating oil that are derived from processing the crude oil. This happens in the so-called refineries. The oil products can be finally consumed in the various sectors where crude oil is only supplied to refineries. As indicated in the oil refineries row in the matrix, all primary energy sources in the form of crude oil is consumed at the refineries. This is shown by the minus 492 megaton oil equivalent. All of this is converted into oil products in the amount of 492 megatons oil equivalent. Let's now focus on the row of electricity plants. Various primary energy sources are used to generate electricity, and the amount that is supplied to the various plants is given with a negative number. The energy source is being consumed. The coal is used in coal power plants. diesel or product is used in, for instance, diesel generators, the gas is used in gas power plants, nuclear heat is converted into electricity in nuclear plants, etc., etc. The total electricity generated in these various types of plants in 2023 was 105 megatons oil equivalent. If we focus on the total column, we can see that about 166 megatons oil equivalent of primary energy source got lost during these conversions. The data in the row of the electricity plants can be used to calculate a general conversion efficiency for primary energy sources into electricity. As discussed before, the conversion efficiency is equal to the ratio between the output energy and the input energy. Based on the principle that energy is conserved, input is equal to the output plus the loss. If you plug in the numbers of 105 megatons of oil equivalent electricity generation and 166 megatons oil equivalent loss, we find that the average conversion efficiency is equal to 38.7%. If we consider typical conversion efficiency of nuclear heat into electricity of 33 to 37%, the conversion efficiency of coal plants ranging from 33 to 45%, and the conversion efficiency of gas plants ranging from 35 to just above 60%, the found general conversion efficiency of 38.7% makes sense. The total primary energy source, renewables, include more than one type of energy carrier. It contains the chemical energy in, for instance, biomass, but it also includes the wind, solar, and hydroelectricity as well. For photovoltaic energy, the solar radiation incident on the PV modules would be the primary energy source. For wind energy, it would be the kinetic energy incident on the blades of wind turbines. And for hydroelectricity, it would be the potential kinetic energy of the water used. However, those energy reservoirs are never included in the total primary energy source. The electricity of renewables, solar, wind, and hydro is directly included in the total primary energy source. Therefore, the total of 82 megatons oil equivalent in the form of renewable electricity generated is fully contributing to the 82 megatons oil equivalent electricity generated in the row of renewable electricity transfer. It shows that minus 82 in the renewables columns and plus 82 in the electricity column. Combined heat and power plants are mainly powered by coal, gas, and renewables in the form of biomass, and it produces 46 megatons oil equivalent in the form of electricity and 30 megatons oil equivalent in the form of heat. The data in the row of the combined heat and power plants can be used to calculate the general conversion efficiency for primary energy sources into electricity and heat. If you plug in the numbers of 46 megatons oil equivalent of electricity generation, 30 megatons oil equivalent of heat generation, and 40 megatons oil equivalent loss, we find that the average conversion efficiency is equal to 65.5%. Heat plants are mainly powered by gas and renewables in the form of biomass, and it produces 40 megatons oil equivalent in the form of heat, and 6 megatons oil equivalent is lost in the conversion. If we plug in the numbers 40 megatons oil equivalent for heat generation and 6 megatons oil equivalent loss, we find that the average conversion efficiency is equal to 70%. All these energy carriers have their own distribution losses. As you can see, they show up with negative numbers. The losses in relative terms are the largest for transport of electricity. These losses are caused by conductor resistance losses, corona discharges, capacitive losses, and inductive losses and transformer losses from one voltage level to another. In an energy balance, the other category typically accounts for the energy flows that don't fit neatly into primary categories like production, transformation, power generation, or final consumption. It also includes statistical discrepancies, losses like fuel combustion losses not fully captured elsewhere. It acts as a catch-all for residual energy flows in a complex energy systems or balances where specific details are grouped for simplifications. They can be positive or negative. This concludes the conversion and loss section of the energy balance. The total final consumption per energy carrier available for the sectors is the total primary energy sources minus the conversion of the energy input plus the conversion output minus the losses. As you can see, the secondary energy sources, electricity and heat, are solely generated out of primary energy sources. The total final consumption for electricity is 200 megatons oil equivalent, and for heat is 40 megatons oil equivalent. Only crude oil and nuclear heat are the primary energy sources that are fully converted into secondary energy sources. The remaining primary energy sources, not used for conversions, like the remaining coal, oil products, gas, renewables and waste, are finally consumed in the sectors as well. The total final energy consumption for the European Union in 2023 was 941 megatons oil equivalent. Let's consider the end consumer section of the energy balance. This is represented by the right-hand side in our Sankey diagram. And let's zoom in on this section. Let's first consider the industry sector. Note that although all energy carriers are consumed, they are presented with a positive number in this section. Primary energy source gas and secondary energy source electricity are the dominant energy carriers consumed. In the residential sector, this is gas, renewables and electricity. Not surprising, but in the transport sector, the dominant energy carrier is oil products. And finally, the numbers of the other final consumers and non-energy use are plotted as well. The total final consumption energy carrier is the sum of the column below it. So for example, 60 megatons oil equivalent of coal is a total of the final consumption is equal to 9 and 5 and 1 and 1 megatons oil equivalent. And finally, we have constructed the total energy balance of the energy infrastructure of the European Union in the year 2023. A disclaimer. If you will search for the real energy balance of the European Union in 2023, for instance published by the International Energy Agency, you will find much more detail in the energy balance. The energy carriers as presented here will have all their subcategories. The conversion plans as presented will have all their subcategories based on different technologies as well, as the various sectors will have their subcategories. For the sake of simplicity, I have summarized them in the general energy carriers, conversion technologies and important sectors here. Energy balances are an excellent tool to analyze the total energy supply and demand of a country or region, to analyze the region's energy security, analyze the economic efficiency of the energy systems, analyze the progress on climate goals and support policy decisions by providing a comprehensive, comparable view for past, current and future energy systems from production to consumption by the sectors. It's a crucial tool for planning, assessing data quality and managing the transition to sustainable energy. Now we know how an energy system looks like. Having said that, we know how the current energy system looks like. We also know how to visualize such system in a Sankey diagram or to quantify it in an energy balance. In the next video, we will discuss what the impact of such energy system that still heavily depends on fossil fuels will have on the climate of planet Earth. So see you in the next video.